他上课也没听嘛，因为嘛，哦，哎，这里现在要开始了。
请起出盖头。
Hello, testing. Okay, we are close to finish the whole semester. There's only two more sections left. Okay, before we finish this improper integral, there'll be last two more section. One section is on the finding the length, the area, surface area. Then that chapter is pretty short because we're gonna skip the physics part. And for the last one is the differential equation. That chapter, I think we will mainly focus on calculation only, not much understanding. Yeah, focus on the technique of the integration of the differential equation. And the differential equation you learn will be very simple. So after that, then we'll finish the semester. And so I think there's one more quiz to come up. Wait for the announcement. I'll let you know again once we fix it. So there's some question from Yuhen last week, right? Yuhen asked about this question here. Okay, so if you look at this question, right, determine whether this function convergent or not. If you notice the integrand, it is actually odd function. Okay, odd function. So odd function means what? Fx equals to minus x minus x. Okay, and then we learned that if you integrate along a interval that's symmetric at the zero, what do you get? You get zero because it is odd, right? So the positive part and the negative part will cancel out. But turns out that we say that it is divergence. Why? Why do we say that it's divergence? Okay, so maybe you might think that, oh, because it's true for a finite interval, right? Then we can take limit to infinity. So the limit, the positive side and the negative side to the limit to infinity is zero. Okay. Well, you could define like that. That definition is what we call the Cauchy principal value. Okay. This is what Cauchy principal value would dig for us. But usually we don't define like that. Okay, if you remember how we define this uh, limit calculation here was we have to split it. How do we split it? Let me see where's the definition. Do we have this definition? Where do I get this question from? Yeah, so we have to split this function into two integrals. This left-hand side here convert only when both of these converge. Okay? If both of these converge, only this converge. Does it make sense? We are not talking as a whole. What is it as a whole? Okay, we have to talk about these two separate things to converge first. Okay, and then just now we proved that that two separate thing is not convergent. Okay. Well, there's a very good reason that why we don't want to do that. Okay. There's a very good reason. I asked Gemini. Gemini gave me a very good question, good examples here. So this is a very good example why we don't want to talk about that Cauchy principal value there. It's because if you look at this limit here, this is also going to infinity on both sides. One is positive, infinity, one is negative. Okay, but at a different speed. At a different speed. One of the speed is 2t, one of the speed is just 5. Okay, so one go faster than the other. So if you calculate this, right, what do you get here? It appears that this number here is finite. Okay, so it's not very consistent with this definition because once you change the limit, the speed you go to infinity, then the integral will compute to something else. Okay, doesn't so it really depends on the how you go to infinity. That makes sense. So this integral is sensitive. So when you take limit, right, it's sensitive to the speed how you go to infinity. This is not for test, but this is for your extra knowledge. Okay, so why we try to split the infinite integral out? Okay, no? Does it make sense? Okay. Okay, so if you take the same speed, maybe you can get what you want, but if you take different speed, you will get different. So that's why we don't define the infinite integral like that. Okay, another question is, another problem is we try to determine the integral of this 1 over x to the p here. So when is it converging? And so let me draw a picture here. So this kind of integral is concerning the function, okay, that go to infinity at 0, but we still want to integrate from 1 to from 0 to 1 like that. Okay. Then f limit of x to 0, f will shoot up either to negative infinity or to infinity. So we put a modulus there. Okay, so I mean like by intuition, you think that, oh, there's an infinite thing to fill up when you go to infinity at one time, right? But last time we said that if it is decaying faster or it is increasing uh, fast enough, then actually it only occupy a finite volume. Okay, for some cases. Okay, in particular for this kind of function, right? We show that this function only converge when p is less than 1. Okay, so when p is less than 1, what does it mean? When p less than 1, strictly less than 1. Okay, so what kind of function you got when p less than 1? So let's say this is 1 over x to the p, and then p less than 1. What could happen here? So either p is less than 0, p equals to 0, or p in between 0 and 1. Like that. Okay, does it make sense? So when p less than 1, what could happen? So when p less than 1, 1 over xp is just x to the minus p. Okay, meaning it is positive. Okay, so it is positive. Maybe it will look like let's say p equals minus 2. So x to the minus 2 is like this. Okay, so it's like a finite area here. Okay, finite area. But when p equals 0, when p equals 0, what do you get? You get a constant function. Right, you get a constant function. This is 1 over x 0, which is 1. Okay, but when p is in between 0 and 1, what do you get? Well, you get something like x to the 0.2, something like that, or x to the square root 2, right? Is one of it. Okay, so 1 over square root 2 looks like what? Also looks like this. Okay, turns out that there's a finite volume that it span here. Okay, because you can imagine that when p is equal between 0 and 1, right? What is x? Let's say, okay, so let's say, for example, look at our square root x case, right? So if square root 0.1, what do you get? What do you get for square root 0.1? What is square root 0.1? Any idea? Any idea? Square root 0.1. Your calculator. Try. What's the square root 0.1? What's something that square to 0.1? Huh? 0.3. Okay. 3 is okay. 0.3 like that. Around, right? Around 0.3. Then you can take 1 over it. So what do you get? 1 over 0.3. 3 point something. Right? 3.33. So let's say if you take 1 over 0.1 square, so can you compare what are they? So 0.001, right? And then what do you see? Let me see. Right. So here you will get what do you get? 1,000. I don't know. 1,000 yes. Okay, 1,000. Okay. So what did you see here? So if you look at the point 0.1, right? Okay, if you look at the point 0.1, you look at the point 0.1 here. If you look at 1 over square root x, okay, this value here is just 3.33, but the 1 over x square function, right, already go to very high number, let's say like 1,000. So can you see the difference? Can you see the difference? So let's say this is 1 over, so this black one is 1 over square root x, and then this blue one is 1 over x square. Can you see a difference? Can you see that 1 over x square has a more area than 1 over square root x? Okay. So this 1 over square root x has less area until you can calculate it. It's a finite number. Although it goes to infinity also when x goes to infinity. Okay, makes sense. Okay. Yeah, any questions so far on these topics? Any questions? You try the lecture examples. Does it work out? Yeah, please try. Please spend time to try at least. Okay. After you try, you can go, mama. Yeah, you can go and play. Please try first. Okay. If no question, we will go to the next part. Go to the next. So next part is concerning the infinite happening at the interior points here. So let's say you have a function that looks like this, okay, f, but you want to integrate from a to b that contain this c, okay, where the x to c of f is infinite. Okay. Previously, what we studied was what we did was we try to integrate from a to b, but your function will shoot out at a, for example, or b, one of the at one of the endpoint. So now the infinity point happens in the middle. Okay, so what we're gonna do there? Okay, so what we're gonna do there is we just split our integral at the infinity point. Okay, at the point that it shoot out to infinity. Okay, or not? Does it make sense? So there's one thing that you observe here is this endpoint of integral, right, doesn't really matter if the function is not continuous there actually. Okay, so endpoint doesn't really matter. Everything in between A and C is matter. Does matter. It does matter. Okay, everything in between A and C. But endpoint doesn't really matter. Okay. All right. So let's see one example. So how we're gonna apply this? Okay. So not that. We try to prove that this diverge. So this picture looks like this. So 1 over x squared looks like this. And then 1 and minus 2 is here. So you are integrating a part that consists of the infinity area here. Okay. Looks like a Christmas tree. Yeah, Christmas is coming. Did you see a library notice as a performance? Yeah, you can try and come and have a look by the orchestra. Okay, so how are we gonna check this definition here? So first note that 1 over x squared is continuous, okay, on minus 1 to 1, except, okay, except at x equals 0, okay, where in x equals 0, the limit of x to 0 of 1 over x squared is infinity. Okay or not? Okay, except one point here. So then we can split out this integral at this point. So we can split it up from minus 2 to 0, and then from 0 to 1. Okay. Then how do we compute this improper integral here? Then it will be kind of one-sided integration from 0 and from 1. Yeah, from 0. One is from left, one is from right. Then we will use what we know from last time. So because at 0 it should to infinity, right? So we then integrate the limit from t to 0 from the left, right, minus 2, okay, of the definite integral from minus 2 to t of 1 over x squared dx, like that. And then the other one, you take the definite integral from t to 1 instead, and then taking t to 0 as well, but from the positive side, like that. Okay. Then, uh, then, then what did you see here? Then you just do the usual integration. So you get 1 over x minus 2 minus, then integrate from minus 2 to t. And on the other side, you also integrate from t to 1. Okay. And then you just compute. Okay, so you can see that both limit terms here include 1 over t. Okay, so if you take t to 0, this term will shoot to infinity. Okay, so that's why they diverge. Okay, so although this is minus 1 over t, right? But you are coming from the left-hand side of 0. Left-hand side of 0 means what? Negative number. So negative become positive. Okay, so it diverges. Because the limit doesn't exist. Okay, any question? So limit doesn't exist. Really, there are two cases, right? One of them you shoot to infinity. The other is you like a cos x function. You oscillate between numbers. Or you cannot settle down with one numbers. Okay, like cos, right? Because you go from minus 1 to 1, and then 1 to minus 1, and then go back and forth. Okay, cannot settle down to one number. So there are two kind of divergence. Okay, any questions so far? Is it clear? Clear what we're doing? Okay. If no question, how about you try this? Or maybe you tell me first, where should we split? Can we split? Should we split? Or where can we split this integral? Can you tell me where to split first? Sorry? Xiangci, you want to try? X to 1, why? It cannot be 0. Another way to talk about it after you learn calculus. It's not defined, right? Okay, it's not defined there. So if it's not defined there, it implies what? The new term you learn in the continuity. So it's not defined there, so meaning the function is not continuous. Okay, not continuous at x equals to 1. Okay, but your integration domain here include 1, right? 0 to 3. So you split from 0 to 1 and then 1 to 3. Okay, I give you 2 minutes. Try and compute this. Okay. Any idea how to integrate this 1 over x minus 1 to the 2 over 3? Any idea? Any technique we can use here? It looks like a polynomial, no? Can we make it looks like polynomial? Yeah. Any idea how to integrate this? You heard? No idea. Hmm. What's the first thing you should try when you do integration? When you do integration, that's the first thing you should try. You should try substitution. Yeah, you should try substitution. Any substitution can work here or not? Yeah. Try first. Yeah. You try first, and then turns out that it's already enough. Right. So if you let u equals to x minus 1, du equals to dx, right? Then your integration domain will change as well. So I want to remind you again, and again, please change your integration domain after substitution. Because in case there are people not doing it. Okay, so get from minus 1 to 0 of dx of u of 3, and then 0 to 2 dx of u over 3, and then If you push it up, you'll see that this is a very easy thing to do. Okay, so because this is an improper integral, right? Is it improper? Yeah, it is improper. So you need to take the limit of the definite integral. Plus. Okay, so maybe I want to remind you right here, because if you take limit, again, this one like this minus, because if you take limit when x goes to 0, okay, and a modulus of u less than 3 is actually infinity. Okay. When one side of your integration limit give you an infinite limit on your function, right? You have to consider this improper integral. Okay, this is where you use the improper integral. Okay, because your function should to infinity on one side. Okay, so your function looks something like this. When this close to 0, it goes to infinity. So you need to use this proper, okay, improper integration. So meaning you compute from 1 to a value t. Okay, and then you take this t close to 0. All right, so I think this calculation should be easy. Easy or not? Okay, so let's see. Okay, it turns out that this integration result is very pleasing. Just 3 to the u of 1 over 3 is a very nice cubic root function here. So you get minus, right? What's this? Uh, what's this? Minus, because minus minus plus, huh? So become 3. And then on the other side, uh, 3 of 8. Ah, right. In my own note, I forget to change the limit. Okay, so here it becomes cube root 2 minus 3 cube root 2. Okay, so altogether you get 3 plus 3 to the cube root 2. Is it correct? Let's check. Please check my answer. Okay, so far, any question? Any questions so far? Your midterm actually finished marking already. If can, maybe I'll try to discuss this week. If not, maybe next week. Okay, you will have a chance to see your test paper, but you cannot get it away. You need to return it to me, and they are scanned because the school need it. Okay, any question? Okay, everyone okay with this calculation so far? Okay. Okay. If no question, then we will proceed to the next one. Okay, then we will have a comparison test for improper integral here. So suppose f and g are continuous function, okay, with fx on top gx. So you can look at the picture down there. So fx there above gx, and both of them are positive, greater than or equal to 0. Then we'll say that if fx, the integral of fx from a to infinity converge. So from a finite a to infinite converge. So is the integral of gx from a to infinity over converge. Does it make sense or not? Because g is below fx, right? So g will bound less area than f. So if f is finite, g also will have a finite area. Area of f is finite, area of g also finite. On the other hand, if the area under a g diverge, obviously the area under f also diverge because area of f must contain the area of g. Okay, so this is the other way around. Does it make sense? Okay, please don't confuse. Please don't confuse. If G converge, does it mean that F converge or not? No, right? Because F can go arbitrarily large. Right? If F diverge, does it imply G diverge or not? No, because G can be very low. G can be just zero, which is zero function also can. Okay, then the integral is zero, so it converge. Okay, also can. Okay, we will learn this, and then I think in next semester you're gonna see this again. Okay, in next semester you can see this again. So then I think we will only have two questions to look at. Okay. So for example, in this question here, determine whether e to the minus x squared is converging or not. Well, okay, so we plot this graph for you, e to the minus x squared, and then we also show you e to the minus x. Okay, so what's the reason here? What's the reason here? Yeah, what's the reason here? So we are trying to integrate from 0 to infinity, right? But can you see what happened here? Can you see what happened here in this picture here? How do you compare e to the minus x and e to the minus x squared? So this question asks whether it converge or diverge. So you need to decide. You want to prove that it is converge or diverge. Okay. Wow. So what's the reason I draw this picture? What's the reason picture here is drawn? Can you see? Can you guess? Can you think about it? Why? Based on what we know just now, can you like think of a strategy to use this picture here? And then we're gonna test your strategy. Any idea? No idea. Can you compare the blue line and the red line? Blue and the red. Okay, so when is it the blue below? When is it the blue above the red line? Based on here. Can you see? Which one is higher? Which one is lower? Huh? It's different. It's different. At different region, this blue will stay below. At different region, this blue will stay above. Yeah. So at which region this blue graph stay below? 0 to 1, right? Okay, when x equals between 0 to 1. But when x is greater than 1, this blue graph here will stay above the red graph. Meaning what? If we can show that the integral of the blue part here, the blue curve here, converge, okay, from 1 to infinity, then this e to the minus x squared here will also converge for the integral from 1 to infinity. Does it make sense or not? Okay. Well, I claim that this is already enough to show that this integral here converge. Why? Because we can split this integral into two parts, right? One is 0 to 1, one is 1 to infinity. So if we show that 1 to infinity converge, can you see that the integral between 0 to 1 must converge as well? Because this is just a finite part. Right? This is a finite part. You can compute the integral. Does it make sense? Okay. So we're gonna try this. Okay, let's try this. Let's try it. Okay. Shall we try showing showing x greater or equal to 1, e to the minus x will be greater or equal to e to the minus x. Let's show this first. Okay, let's show the relation between the blue and the red graph first. So is this true? Okay. So the proof of this claim is so well, shall we work backward? Shall we work backward? Oh no, maybe no. Okay. So proof, we will have that x squared will be greater or equal to x. So let me write here. For x greater or equal to 1, x squared will be greater or equal to x, which is greater or equal to 1, which is greater or equal to 0. Okay, this implies what? This implies that if I put minus on both sides, we actually get that 0 is less than or equal to minus x squared, which is less than or equal to minus x. So we swap the sign, right? And then this would implies that e to the minus x will be greater or equals to e to the minus x squared greater or equals to 0. Or if you like, maybe e to the 0 and then greater or equals to strictly greater than 0. Okay, does it make sense? Okay, so we have shown this blue graph is greater or equals to the red graph in the region of x from 1 to infinity. Okay, make sense? Do you think that if we don't give you this graph, can you figure out this? It's a bit hard, huh? A bit hard. Okay. Yeah. What if I just give you this and then ask you to compare? Can you think of this? Okay, maybe this is something you need to learn. Okay. At least I will give you this to compare. I wouldn't tell you which one is larger, which one is smaller, but try and find relation between them. Okay, but you can see that this relation actually rooted from this very simple relation here. When x greater or equals than 1, x squared will greater or equals to 1. Is it true? For example, 2. What's 2 squared? 4. 4 is definitely greater or equals to 2, for example. But this is not true for number in between 0 and 1. Because when you have 0.1, 0.1 square is not greater than 0.1. Does it make sense or not? Because 0.1 square is 0.01. What happens actually? What happens was, if you write 0.1 as 1 over 10, right? Where are you squaring actually? You are squaring on both sides, numerator and denominator. The numerator is always 1, but the denominator become large. Denominator become large, make the fraction become small. Yeah, okay. Right. Okay, so after this, then we should use comparison tests. Okay. If the larger integral converge, then the smaller integral will also converge. So if the larger one converge, then the smaller one will converge. What's the smaller one? Okay, so now it suffices to just show for the larger one. Okay, so let's do the larger one. Okay, if we compute this, what do we get here? Okay, again, so you can see that this, you need to take integration at the infinity. This means what? This is an improper integral. Okay, so improper integral have few types, right? One, you take integration at infinity. Second, it is not continuous there. In particular, at the discontinuous point, the function shoot to infinity or negative infinity. Okay, so in this case here, you should use the improper integral, which involves this limit of a definite integral. Okay, so definite integral is something you learn. Okay, a fixed integral. Okay, so if you integrate minus e to the minus x should be easy. So here you get minus e to minus t plus 1 over e. So what is t goes to infinity? minus t go to infinity is minus infinity, but you are divided by 1 over e to the t, right? Okay, so e to the t goes to, if t go to infinity, e to the t goes to infinity, 1 over something go to infinity is 0. Okay, so you get 1 over. Okay, does it make sense? Yeah. So what we can conclude is integration from 1 to infinity of e to the minus x squared dx converges. Okay. Are we done? Are we done yet? Are we done? We done? Not yet, eh? Because we have to integrate all the way from 0, not just from 1. Okay, we only show that this part here exists, but we still not sure what about starting from 1. But we know that the integral from 0 to infinity of e to the minus x squared dx can be split up to integral from 0 to 1 of e to the minus x squared dx plus integral from 1 to infinity of e to the minus x squared dx. So you just need to compute the integral for the first part here. Okay, for the first part here. Is this integral easy to compute or not? You cannot do, oh, this part is hard to compute actually. This is slightly hard to compute, I think. Uh, this is slightly hard. So, how are we deduce this? So we're gonna just deduce this as converge as well. So this reason you need to remember because it is a finite integral of a continuous function on a closed interval. This is very important. And this reason maybe you want to remember. Okay, this is very important because if you are a continuous function at the open interval, you know continuous at the endpoint, right? You have the improper integral again. Okay, but if it is continuous function on a closed interval, then you will see that it bound a finite area. Okay, no. Otherwise you have something going infinity again, improper again. Okay. So this is something that you want to remember. And then for the second part, obviously converges by comparison. That's why you have two finite numbers. I think this is hard to compute. I think you cannot use integration by part or substitution to do it. This is hard. This is actually will be done in calculus 2. Okay, where we will change this. We will do some change of coordinate. In fact, we will use polar coordinate to do it. Okay. Because if you imagine you use substitution, what did you get? Like y equals to minus x squared, right? Then dy will have minus 2x. But there's no minus 2x for you to replace here. Unless there's a 2x here. Yeah. Then you can use substitution. Otherwise, it's hard. Okay. Yeah. In fact, this has to be done through a polar coordinate. It's easier. I don't think you can do by parts, right? By parts will make this even weirder. Okay, by part will make this even complicated, more complicated. Any questions so far? Question? Okay, so maybe this facts you need to remember. This is a very useful fact. Okay, as long as you have continuous function of closed interval, then this thing is fine like this area. If it is not closed, then you will have some improper integral coming up again because you might shoot to e or something. But let's say your function, so there's some exception. Maybe I can draw some exception for you. So maybe your function just continuous. Uh, or should I any other? Yeah. So maybe your function just continuous like this, but not continuous at this point. In this case, you still has finite. You still have finite area. But then you cannot include these cases as well, too, okay? Because it might the way that the function is not continuous, it could be shoot to infinity. This is the problem. Okay. If it is like this kind of case, not continuous, but there's a limit exists, still okay. Okay, it's still fine. Okay, any question? Any question? Okay, if no question, let's do one more before we take a break because this is the last question already. Okay. Or determine whether this function continuous or not. Sorry, this integral conversion or not. If you don't have any idea, right, maybe you can try and plot it out first. Maybe you can use an app to plot it out to see you think that whether it's converged or not converged. So maybe we will try it together. Right. So let's try and plot it. One. So when we plot this, right, this is really like the old way where you make a table of x and y, right? And then you see whether the value get really large or not. Okay, so what can you see? You can't really see anything because this function is like decreasing as well when x is between 1 and infinity. So you are not quite sure whether it converge or diverge. In that case, maybe I should give you hint. Yeah, in that case, maybe I should give you hint. So can you see that actually 1 plus e to the minus x over x here is actually greater or equals to 1 over x. Strictly greater 1 over x. Is this clear? Is this easy to see? Because e to the minus x is always positive. So 1 plus some positive number. So, well, in this case here, did you know about the integral of 1 over infinity of 1 over x dx? Do you know about this? Does this look familiar? This is what we showed last time, right? 1 over x to the p. What's our result back then? What's our result back then? So let's check. I think example what? 7.49. Okay. Example 7. Okay, so what's our result last time? Okay, when does this integral converge? Okay, so this integral converge only when p is less greater than 1, diverge when p is less than or equals to 1. Actually, we show this, right? So when p equals to 1, where's the calculation? Let me see. Yeah, so when p equals to 1, this is the calculation. And because x will go, so this is the improper integral. So we make it into this limit of definite integral, and then we compute this ln x here. Okay, but so what is ln t when t goes to infinity? Okay, so unfortunately I cut this off, so I should add it in. So here is t to infinity, here is t. Okay. So ln t here go to infinity, so diverge. Okay, so what can you conclude here? So the smaller integral here has diverging area, meaning what? It will push this area into diverge as well, because the larger function will contain the area of the smaller function. So this integral here diverge implies that the integral of 1 to infinity of 1 plus e to the minus x over x dx also diverges, okay, by the comparison test. Does it make sense? Okay, so if you go back to this picture, Although you can see that, oh, this function kind of like decrease really fast, but it contains another 1 over x below it that already diverge. Okay, no? It contains a function of 1 over x below it that also diverge. Maybe I can plot 1 over x to compare both of them. So 1 over x. Okay, so can you see 1 over x and 1 plus e to the minus x over x? Really close actually, you see? Really close. Very close actually. I cannot split them out anymore. Very close. So maybe I need to go very big, you see? If I go zooming very big, only there is a difference. It's almost the same already. Can you see why it's almost the same? E to the minus x, when x go to infinity, what do you get? 0. So almost like 1 plus 0 already, if x go very far. Okay? 1 plus 0. Does it make sense? Okay. Yeah, any questions so far? Any question? But you can see that when x is less than 0, right, they are quite different. They are quite different. When x is close to 0. But when it's far going to negative infinity, it's very different. Okay, any questions so far? Okay, if no question, then we will take a break from 10 until 11:07. Okay, if you haven't told me your project or your leader yet, please report to me. Hey. Okay. Off 啊，这个是 off at，这个是 off at，off，对，这个 off。
Use functions close，这个是
那个是，
这个
对，这个是什么意思？等一下先，这个是 for off，这个不是 on。OK，然后 off 的意思就是说你有一个 continuous function 嘛，然后这个 continuous function 是 continuous 在一个 closed interval 上面，就意思说在每一个点这个 closed interval 的点上面，它都是 continuous，它有 limit，然后f 也 define，然后你可以算它的 integral，你的 integral 就是从 a 到 b，这是一个 finite integral，然后这个说 finite integral 的话，这一个 integral 就会 converge，就这样，就会有一个 finite number 就是这一行哦，就是这一，
就是现在就是你
对，但是你要但是你要确保你是在对的情况下把它写到，就是basically 就是它的意思就是说这个 function 是 continuous 的，因为它 limit exist，然后它也 define 在0到1。如果你是 finite integral of 一个这种 continuous function 在 closed interval 上，它就是会看得懂这个图吗？所以你 continuous 的话，你的 area bound 是 finite。
应该
Yes。
subject
还没 OK。你是第几组来的？
convolution how to use convolution
，rush 软件。
哇哦，OK，不会太难。
嗯，
你用到什么 derivative？
check 看一下。
你是用 derivative 吗？那个不需要到 vector calculus 哦。
嗯，this one a little bit large。
哎呀，这个需要多维耶啊，这好像要需要3D 耶。对呀，这个好像是需要到 line interpret 之类的。你们觉得做个来？你看，它需要是我们只是 one variable 吧，
厉害啊！
有点难哦，因为这个是 calculus 2的东西。如果能的话，可以规范进只有 calculus 1里面，就是 one variable，因为这是 two variable。
就是别的什么都是什么 subject。
他们就是从我的那个 list 里面去分，那是课本的 list 哦。
我再瞅瞅，
你再瞅一下，
我感觉
再对一下，这个是 calculus 2的东西，
OK。
尽量在 one variable 里面。Real Okay, yeah. Let's take the this 雅婷 here, not 雅婷，不是雅婷。很烦，God, yeah. I see you. I see you. 伟业，not here. 洪亮，yeah. 闭合，yeah. 乐天，good. 瑞阳，若实，yeah. 诗曼，意南，yeah. 玉超，超，一泽，一文，yeah. 瑞妍，可汗，加来，加分，嘉莹。平均，一清，俊逸，相思，一零，冰镇，嘉团，奥运，文琪安祥金杰新阳万达心愿，yes。OK，玉团呢一田冰城呢，yes，OK，可以，OK，冰城，哎，冰城 already 哈，浩然Desmond I didn't see Tommy got Chong Yi you got your calculator. Okay. Go Pagani. Let's go Pagani. Go Pagani here, no? Not here. Oh, here, okay. Arthur, okay. See you. Okay. Jose, I think I see Jose, yeah. Hisham, yeah. Daniel, is Daniel? Okay. Hashim, Yusuf Hashim. Bin Yusuf Hashim, not here. Okay. Madia, not here, Madia. Aaron Brandon Alicia Gunakanti here, no? Yes. Margaret, I think. For you. Gavin, okay. Gabriel, okay. Jeffrey got 20 yes. Football, was it?
What was
Oh, okay.
？Infinity 切什么？就是
哦，为什么切成两个呢？因为我们想要说它 converge 嘛，因为我们想要用这个来说它 converge，因为这一个 integral 我们 算不了了，其实就算不了。然后所以我们要用 comparison 咯，所以这一段的话它是高过
是
它嘛？OK，知道。OK，但是因为前面这一段我们不能够用它来证明同分，因为它提把下面。
哦，好的，明白。看一下，我写了两个字，就是上你是比把这个这两个
OK，
再比较
分开
比出来，这两个都是算的。
Yeah，
嗯
嗯
对，
嗯，
怎么能比上这个好呢？这个，它这个是
哪一个？
这大于一，然后这
大于一是哪比较？0到1是几分？0到1是另外一个名
哦，你应该在上说
啊，在上面它就要不能够用，
不能说都算不了，为什么1到1就可以算？
啊，0到1的原因不同，0到1的原因是因为它是一个 finite integral of 一个 closed function from 这个 closed integral，这个可能是你要知道的一个 fact，我们没有 proof，但是你要用这个 fact，就是你需要确保你的 function 有在整个要 close，就是说它的 endpoint 都要比较怎样？因为如果不 continuous 的话，可能它是 finite，但是也有可能不 finite，所以我们不能够下结论，如果它就是 continuous 在 open interval 的 endpoint 是蛮重要的。
就等于这个范围是直接知道，因为它是就知道是肯定的，然后
对，
然后就开始，那就是差不多是直接看出来，
啊，
差不多是直接看出来这个范围。
这个 fact，因为我们没有 proof，所以你只能够记住哦，这个是可以证明的吧？
谢谢。
OK. Okay, a lot of you asked about this facts here. This facts here you need to for your I think for the purpose of this class you need to remember. Okay, because we didn't prove it. Unless you come to MA here, we will prove it. But then because why? Because this question you really cannot compute with whatever we learn now. With the technique that we learn now, you cannot do it. You can't do it. So far. Okay, we cannot do it. Yeah, so that's why you are forced to use this comparison test. And then because for the first part, this function that we compare here is below it. So we cannot say that, oh, the function below converge and the above converge, because you can imagine that this function may be called very large, right? But the point here is you cannot go very large. Why? You cannot go very large because it is a continuous function on a closed interval. You cannot go very large. How large you go, it will be finite as well. Okay, you cannot go very large. Okay, you can go very large unless it is not continuous, so it diverges. You can go very large. Okay, but if it's continuous, you cannot do that. You understand or not? Okay, so if it is a continuous function on a closed interval, your function cannot grow very large. And it has to be continuous. The limit has to exist, and then it has to be defined. Every value must be defined. So it's a finite value at every point. Okay or not? Does it make sense? Yeah. Okay. All right. Next part, we will have further application. This application will be application in geometry again. Okay, so we are counting lines here. So for example, we can compute the arc length of a curve. Okay, so what you should imagine is this blue line here. I wanted to. So imagine I have a rope. I give you a rope. How do you measure the rope? Can you tell me? A rope. I hand you a rope. How do you measure? Felicia? Sorry? Length of the rope. Huh? I give you a rope, right? Go and measure. How you measure? You tell me what's the procedure. Sorry? Using a ruler, huh? You get something that's straight first. And then you need to straighten this out. Right, correct or not? But in this case, how to straighten this curve? Cannot straighten. So instead, what we do is we also take ruler. So meaning straight line. So we use straight line to approximate. We use some fixed straight line to approximate. But do you think this is accurate? Yes, yes, man. How is not the same. How is it accurate? So what happens here? Your curve is curved, but your line is straight. So meaning what? You miss some of the part of your line. So what can you do? What can you do to improve this method? The straight ruler method here. Huh? I can use a smaller ruler so that I can miss less line. Understand or not? So I can use a smaller ruler. You see, I use a smaller ruler so that I can make sure I have a minimal loss of my length. Does it make sense? So this is kind of a limit process again. We take a smaller and smaller and smaller straight line to approximate this curved line. Okay. So I won't show you this derivation here because this derivation actually needs the mean value theorem, but we didn't prove it. So maybe you just take what it is here. Okay, you just take what it is here. So this means that actually, if you want to integrate from A to B of this line here, dx, this is defined to be this integral here. Okay, so this integral here includes what? Square root of 1 plus dy over dx squared. Okay, maybe you might think where this come from. How about if I play around with this a bit? Let's say I can multiply in. Can you see what's going on here? This is something looks like a Pythagoras theorem. This is looking like a Pythagoras theorem. So this dx dy here actually happening around here. So this dx dy. So dx is the thing that we want to measure. Okay or not? Can see or not? Dx square plus dy square, and then square rooted is this dx thing. Is the straight line. It's the straight line ruler that we want to use. Okay, make sense? Okay, so why have this integral sign? You should now at your mind that remember that this integral sign is some sort of limit. Riemann sum. You want to take the width of something going to 0. Okay, so you are taking this dx here going to 0. Okay, so you use a smaller and smaller rulers to measure it. Does it make sense? Okay. So this formula, I guess you can only memorize for now. If you want to remember how to memorize, maybe you can think of this. Okay. Okay, so another thing to see from this formula is what? This formula here actually relates the derivative of your function. Okay, so actually you are using the derivative of your function to measure the length. Does it make sense? You use how your function change to measure your length. Okay or not? You use this derivative to add up. Obviously, you take the square of the derivative and then plus a 1. Maybe you don't know what the 1 come from, but yeah. Okay, so actually you are using the derivative to measure the length. Is it amazing? You use derivative to measure the length. Okay. Yeah. So let's do some computation. Let's do this classic examples here. Okay, circumference of a circle. That's circumference of a circle. So do you remember what's the circumference of a circle, in particular of radius r, center at 0? You memorize from your school, right? What is it? Circumference 2 pi r. Okay, so we're gonna use this method to compute it as a 2 pi r. Okay, so in particular we'll see where the pi come from. Let me see. Am I saying right? Yeah. In particular in this calculation, you will see where the 2 come from, where the pi come from, where the r come from. Okay. Yeah, why is it 2 pi r? Why is it not some other thing? Okay, so why is it 2 pi r? All right. So to this end, how about let's draw it. Let's see how this 2 pi r come from based on this arc length formula here. Not symmetry. Let's move it around. It's better. Okay, so how to compute this circumference here? So at the moment here, there's no function yet. There's no function here because this function is kind of implicit. If you still remember from the first chapter here, it doesn't pass the vertical test line. So how to make it function? Or maybe you need two functions, right? If you still remember all the way from the first few weeks, we split this into a semicircle, upper semicircle and lower semicircle. The top part is y equals to square root r squared minus x squared, right? And then the bottom part is r equals to minus square root r squared minus x squared. Okay, make sense so far? Yeah. Right. Okay, so which side you want to compute first, top or bottom? Maybe let's compute the top first. Okay, let's compute the top. What's the length of the upper semicircle? Well, to compute it, what's our formula? Maybe let's keep our formula up first. So we want to compute the arc length of the top of the upper semicircle. What we need AB and then square root 1 plus dy dx square and dx. Okay, so what's our AB here? Why do I label here is R? What's our AB? Okay, so we are actually integrate from minus R to R. Okay, minus R to R. And then what's our dy dx? Okay, can you quickly differentiate what is dy dx here? You know how to differentiate this? You need to use a chain rule because there's a square root. And then there's in fact there's a linear change. Can someone tell me how to differentiate this? What's the answer? Chain rule. How to apply chain rule? So you let g equals to r square minus x square, right? Should I do it step by step? Y dy over dw and then dw over dx. And then what's w here? W is r square minus x square. Okay, using chain rule. Okay, and then dy over dw, what is it? Huh? No one know. Dy over dw. Differentiate w to the half. So what do you get? 1 over 2 of w the half. And then dw dx minus 2x. Okay, and then if you put it back, what do you get? Minus x over square root of r square minus x square. Okay, so by chain rule you get this. Okay, so then you put it 1 plus minus x square r square and square. Yes. Okay, so maybe you might think that, oh, this is very ugly, but if you expand it, it's actually very nice. Okay, if you expand it, actually it's very nice. So you get r squared minus x squared, r squared. Okay, can you see what I'm doing here? So I square the fraction and then I make them the same denominator. Okay, so you can see that something cancel out. There's something really nice canceling out. So you just left with r squared over r squared minus x squared. Oh, how to integrate this? Any idea how to integrate this? You have a square root, you have a squared r squared minus x squared. So there's a difference of square inside square root. You should use the trigo substitution. Okay, trigo integration. Which trigo integration then? Well, you can try and plot out the, the right angle triangle, right? So you have a square root r squared minus x squared here. Where to put this? Okay, where to put this is a problem here. So you should remember the universal Pythagoras theorem, right? Okay. So you can see that the hypotenuse square is always staying on the other side. Okay, so because you have a r square minus x square, right? So where's the appropriate place to put r and x here? Okay. So to get a minus sign, you should think of like this. So c square minus b square equals to a square. Okay, this is a proper way to produce this minus sign. So you should think of that r as a hypotenuse. Okay, so you put the hypotenuse as your r, and then where do you want to put the rest? I think the rest should be quite flexible. So you put r on the hypotenuse and then x on the adjacent. Then your opposite will be the thing that you want to substitute. Okay, so in this case here, what am I substituting? Actually, so I actually got the relation that, so use trigo integration. So actually I set adjacent over hypotenuse is cos, right? Yeah. So become x equals to r cos theta. Okay, so this is coming from cos theta equals to pi s adjacent over hypotenuse, like that. Okay, then dx become minus r sine theta d theta. Okay, so far so good. So after this change, right, your integration limit will change as well. Okay, so what's your integration limits here? So one of them is r, one of them is minus r. Okay, then in this case, what do you get? One of them you get cos theta equals to 1. One of them you get cos theta equals to minus 1. Okay, but remember, where do we get this region of theta from? Okay, where do we get this region of theta from? Okay, so cos maybe look something like this. Okay, so if you go and check, actually we are just picking from the region from 0 to pi over 2 because this is already enough to cover the region from minus 1 to 1. Okay, this is the 1 to 1 domain that we pick. Okay, so we pick from 0 to theta from 0 to 1. So in this case here, if cos theta is 1, theta is 0. If cos theta is minus 1, theta is covered. Okay, so can you see that pi over 2 appearing now? Okay, so this is how your pi come out in your formula because you use the trigo substitution. Okay, and then in this case here, what do we get? Well, let me see. I'm doing here. Okay, good. So let's continue. So the top here is just r squared. Okay, but the bottom here become what? R squared minus r squared cos squared theta. And then you change your variable already, right? So you get a minus r by theta d theta like that. Okay, but if you simplify this, what do you get? You get r squared over r squared of 1 minus cos square theta. Okay, then multiply with the minus r sine theta d theta. Okay, let's continue. Slightly long, this question. Then this r square will cancel. And then the bottom one become what? Sine square theta. So square root sine square theta is sine theta. Okay, then multiply by minus r sine theta here, d theta. So what do you left with? You actually just left with minus r. Okay. Well, so what do you get from minus r here? Well, you get minus xr. So theta r, sorry, theta r, right? R is a constant. If you like, I can pull the minus r out first. Okay, so become a constant, so you get a theta inside. But then what do you get from here? So minus r times 0 minus pi over 2, which is pi over 2 r. Is this 2 pi r yet? It's not quite. So do I miss something? Hey, wait, let me see. Um, oh, I think I missed something. Did I miss something? Pi r, wait a minute, let me think. Circumference is 2 pi r, right? Yeah, so let me see. I missed something. What happened here? I just compute half of it, right? That's the other half. But if you compute the other half, it is the same answer because it's just differ by a negative. Okay, so if you compute everything here, it differ by a negative. But this negative doesn't matter after you substitute it into this dy over dx. Okay, you're gonna get the same number. But then this is not logic, right? So let's say minus so let's say minus so how about the other half? Not the area, the arc length. So how about the arc length of the upper lower hemisphere of a semicircle? Okay, we claim that it's the same. It's also power 2r. Then the circumference. So right here by a similar calculation. And the circumference will be power 2r plus power 2r, which is pi r. Something wrong. What's wrong? Let's see. Did I pick the wrong one-to-one domain? I don't think so. Let's see. Huh? Yeah. Which one is the half of a circle? Yeah, this is half of a circle, right? Yeah, but on the other side, you could compute the same thing. The other half is the same length. So I think we should get pi r first, then we'll get 2 pi r. Correct? But why here is just pi over 2r? So what's wrong? Let's check. Something's wrong. Did I do the chain rule? Or something is wrong here. We can remove a minus factor. We only get well, let's check to be safe. Whether I pick the right domain or not. I feel like I don't pick the right. Sure. Okay, so what substitution I did? I did the cost one. Oh, the cost one is not inside here. Okay, so not very legit. Okay, so I think the cost one is not inside here. So that's why something wrong here. You see? Can you see or not? Okay, so instead we should use sine. Okay, so I think there's a nice reason why we only keep to this tree. Cos maybe doesn't behave very well. Okay, actually we should use the sine version here. Okay, let's change to the sine version. Okay, so because this is actually square root of x squared minus x squared here. Okay, so that's the reason why we only pick these three here instead of not picking cos. So if we pick the sine one, then we need to swap all these things. So sine meaning I put x here, and then I put the square root. 1 minus x squared here, right? Then we will use sine here. Sine theta, sine is opposite, yeah. So sine, and this becomes positive cos. And then in this case here, we will change our integration limit. So instead, the integration limit will become something in between minus pi over 2 to pi over 2. Okay, so from here, we will see that if we want our sine theta to be 1, then obviously we should be pi over 2. And then for sine, because minus 1, we pick pi over 2. So now we will have pi existing now. So let's change this. So here become plus, here become the cos, then sine, then sine, then become the cos. This one is positive. Power 2. Negative 1 is the negative power 2 is forget. And then here is positive, here is cos. And then bottom here become cos squared, and so square root become cos theta. So you just put out the positive r, negative of power 2. So here is the power 2. So here is power 2 plus minus power 2 plus. So in the end, you really get a pi r. Okay. So for the other side is the same. You will get pi r. So altogether, you will get pi r plus pi r, which is 2 pi. Okay, so far. Okay, now. Yeah. Yeah, I think you also need to learn how to rectify your problems like this. Okay, any question so far? Question so far? No? Okay. So you get this 2 pi. Right. Should we go to the next part? Okay, let's go to the next question. Maybe I'll let you try this question here, but let's discuss first. So this is a length of a line segment from 0, 1 to 5, 13. Okay. Before using the arc length, do you know how to compute this length here? How? And how to compute this arc length? You make a right angle triangle. Okay, so you make a right angle triangle here. So basically, you have the base as 5 minus 0, and then the height as 13 minus 1. Okay, so then what do you get? C equal to square root of 12 square minus, sorry, plus 5 square, which is square root of 144 plus 95, which is square root of 169, which is 13. Okay, so now we're going to use the arc length formula to compute it. But to use arc length, right, we need a function. Okay, so meaning we need a function to describe this line segment. Can you cook up one? You know how to find this function, this line function here? Y equals to mx plus c, right? Or the other formula is like y minus y1 over x minus x1 equals to the gradient y2 minus y1 over x2 minus x1, for example, right? The gradient. Okay, so we'll use this. So y, let's say y minus 1, 0 minus, sorry, x minus 0 equals to y2. y2 is what? y2 is 13 minus 1 over 5 minus 0, right? So what do you get? Y equals to 5x plus 1. Okay, so can you compute the arc length? Yeah, let you try. Give you maybe 2 minutes. Get this. So you should integrate from 0 to 5, right? Of square root of 1 plus what is dy over dx. Okay, compute this. I think the derivative is very easy, right? Because this is a straight line. Huh? Yeah, the derivative is just the gradient, right? So the gradient is 12 over minus 3. Okay, and then what do you get here? This is just a sum constant here. So it is 169 over 25, which is 13. Which is 13 over 5x from 0 to 5, which is 13. Okay, what did you observe here? Before this 13 coming up, right, it is already appearing in your integral already. It's already appearing inside. But then with extra 5 factors here. But then this 5 factors here is cancelled out by this integration here. Does it make sense? Does it make sense what is going on here? Actually, you are multiplying by the length of your x direction. Your x direction is 5. Okay, increase in 5 factors. So it cancels out this 5. Okay, so it's like you have this length of 13, but cut into 5 parts. But you add up all the 5 parts together. You understand? So the ruler is like one part, 5 parts. This is wrong. Okay, so you add up 5 rulers together. So you get 30. Does it make sense? Okay, amazing or not? Is it amazing? Your 13 already appearing inside your integrand before you computed. Okay. So you kind of take your ruler, there's a 13 unit, you cut it into 5 units. Okay, and then you add them up. Okay, makes sense. All right. What time is it? 11:40. Let's see how much we can go. Okay, actually we have 10 minutes. So 10 minutes. Um, maybe we'll do one more question and then we will finish off today. We'll continue on Friday. Okay, how about you do this? You tell me the final answer and then we can check together. I give you also 3 minutes, maybe. By the way, this is not straight line anymore. Hopefully you can recognize this. This curve could look something like this. Square root and then cube. Okay. Any final solution yet? I think you need to use calculator for this. I mean, for the final solution because it's in a radical form. Kind of hard to see what the actual value is. If we do what week is this? This is week 11, 12, 12, I guess. 12. I suspect we can finish by 13. If we finish by 13, we still have 14 week to go. Let me think. Week 14. There's some revision question we had. I can post it out. We can try and discuss those, or you can pick some question from the either lecture note or textbook, and then we can check on those as well. Yeah, we can do it together. Okay, any brave answer? Any brave answer? What do you get? Still calculating? Anyone want to try? Felicia, you got it? Still haven't? Jose, did you compute? Not finished yet? How you know? You get how you? Huh? What did you get? You don't believe. You don't get what you don't believe. This is what Einstein. Einstein also don't believe what he calculated. He don't think that black hole exists. But black hole is in his solution, one of the solutions. You are like Einstein. Doesn't believe what you calculate. Maybe you can use Apple Notes to calculate. Apple Notes can help me calculate. Or anyone have answered? 加成还是加成 Did you have answer? You also don't think you are right. Wow, you guys are very good. So let's draw this question. But did you get any answer or no? What do you get? What do you get? You get a final answer? Huh? Why you laugh? 一天 呢? How about 一天? Haven't finished or what? X to the 32, right? Well, I mean, like, there's no point to not believe, right? If you just follow step. So let's just follow step and see what happens. Well, okay, this is good. This is good. You see, I put on Apple Notes. This is good about iPad here. Oh, sure, away draw this graph. Oh, better than mine. Oh. This is the actual graph. Instead of concave downward, actually it's concave upward. Okay, actually it's concave upward. Okay, good. Well, so let's continue. So what is dy dx? Can Apple help me to compute? Cannot. Okay, we have to compute ourselves. Okay, so dy dx we get 3 over 2 of x to the 1 over 2, right? This one, everyone okay or not? So far? Okay, so far so good, huh? So next, the length should be integrating from a to b. So what's a, what's b here? 1 and 4. And then square root of 1 plus whatever we computed now. So can you see that why we picked x to the 3 over 2? Because this square root will square to x. Okay. Yeah. So hopefully it's easy to compute later. Well, okay, another burden or barrier here. 1 plus 9 over 4x. How to do? Anyone know what to do here? Easiest thing to test. Substitution first. See it works or not. Okay, just try substitution. So u equals to 1 plus 9 over 4x. And then du equals to 1 plus. Okay. Now Apple still cannot do derivative. We have to do ourselves. So du is 9 over 4 dx. Hey? Oh, wait. Okay. 9 over 4 dx. So remember to change your integration domain, right? So please remember. So when x equals to 1, u will become 9 over, wait, x equals to 1, u will become 1 plus 9 over 4, which is 13 over 4. But Apple can do this calculation. So when x equals to 4, can or not? Substitution. Can Apple do that? Let's try. X equals to 4, u equals to 1 plus, I cannot, but we can write it for him. Okay, equal for me. Equal. Yeah. We get the equal. Cannot. Is it my handwriting? No. No. Cannot. How stupid is this? Okay. U is 10. Okay, so we will integrate from 1. Let me see. So we got the 9 over 4 coming up. So instead, we will get 4 over 9, right? Okay, because we change it to du and then integrating from 13 over 4 to 10 square root u and then u. Then what do we get here? So you can integrate this function already, right? Because this is just u to the 1 over 2, right? This is a polynomial. 10 to 13 over 4. And so in this case here, what do you get? This is the big thing that I'm referring to. So can Google help me to, Apple, can Apple help me to compute this? And equal or not? Max error. Where's the max error happening? No one, correct? Check the expression. Okay. How about I remove this equal? Can you equal for me? Correct, this expression. Solve, yes, solve. Good. 7.634. Got it? Everyone got it? Any step you miss that you cannot follow? Everyone got this? Why? What happened, Alicia? Which part? Substitution. Okay or not? Substitution. After substitution, can integrate this or not? Power plus 1 and then divide by the power. And then you just compute. That's it. Hey, why my answer gone? Not very intelligent yet. It's good. Okay. So this is the answer. Apple intelligence. Question? Any question? Okay, straightforward or not? Calculation. So you get the function out, get your curve, and then differentiate it, and then plug in your formula, integrate it. Maybe this part is hard. This part here, hey, cannot zoom in. This part here. Okay, depends on what kind of integral you get. Okay. Start with substitution. Don't random guess. Okay, start with substitution. So a lot of questions, a lot of students ask me, I found out there's not enough time to do exam question. So what's the strategy? So my strategy is don't stop writing. Never stop writing. Just keep writing. I mean, like, even if you're not writing a solution, write something else. Meaning, try some calculation. See if it works or not. Okay, don't stop writing. Don't stop thinking. Okay. If you just stay there, the students say, oh, often I just stay there, think until the times end up. Because you don't write, you just plainly thinking on it. So you don't know where to go. Because once you write, you can check whether your thinking is correct or not, and then you adjust. Okay, so don't stop writing. Okay. Yeah. Okay, any other question? Question so far? A question? Okay, if no question, we'll see you on Friday.